Let's go ahead and graph now this polynomial, 3x to the power of 3 minus 5x squared plus 48x minus 80. Okay, and we first need to write our function f of x as linear factors. Okay, and the way that we do that is we first have to actually find all the factors first. Okay, and so since this is a power of 3 and this is 80, I don't want to use the rational zero test. Okay, imagine trying to do all 30 different rational roots you could possibly have. That would be insane, right? So let's see if there would be another trick here, maybe something that we recognize from our algebra years of how we can factor this. Well, since it has 4 terms, we might want to try and see, can we just factor this by grouping? Because if we can, then that would save ourselves a grip of time, and I mean a grip. Okay, so since I wrote the test, that's probably what's going to happen. So, all right. So let's first put the first 2 terms in parentheses and put the second 2 terms in parentheses. And again, this is called factor by grouping. Take out the GCF out of the first set of parentheses, and we can take out an x squared, and then we get 3x minus 5. Okay, and then here, if we factor out a 16x, oh no, not the x, just the 16. Sorry there. Squeaky, squeaky. Okay, and if we take out just 16, let's see, 16 times a 3x will give us 40x, and then 16 times a negative 5 will give us negative 80. Oh, you were tricking me. So see how those are the same? So that means I'm just going to factor this now. Say if I say, okay, pull out your GCF. Well, look, both terms have a 3x minus 5 in common, so I'm going to pull out a 3x minus 5. Well, if I pull out a 3x minus 5, then the only thing left inside of this whole thing is just x squared plus 16. Okay? All right, so many of you left it like this, okay, and you got a few points marked off because you need to have these in linear factors, which means that when your factor terms should all have a power of 1. Well, this is fine. This one has a power of 2. So like we need to factor this, and we don't have a sum of squares. Like, try to write this as x plus 4, x minus 4. Okay, we can't do that. So what we want to do is that we actually just want to solve right now for x, and then we know that we can take any roots and just do x minus that to get our linear factor. So what's what I mean here? If I were to solve this right now, okay, I would get x squared equals negative 16. Okay, that's all I did was I just bumped the 16 over to the right hand side, and then if I take the square root of 16, that's plus or minus the square root of negative 16. Going back to our algebra 2 days, that's plus or minus 4i. So that means this factor stays right there, 3x minus 5, but then we have our other 2 linear factors is x plus 4i and x minus 4i. Okay, and as you can see here, every factor is linear. And that's what you needed to do to get that full credit right there. And now for the next step, I mean, and that's pending that you got all this. If you got all this, then your roots are just basically set each factor equal to 0. So if I set that equals 0, x equals 5/3. And then we have this right here, right? Plus or minus 4i. And that is all right there. You get your 5 points for just showing that. Okay. And lastly, I want you to graph now with at least 5 points. Okay, and this one got a lot of students because the numbers were so big. But what you're going to see right now, you're going to be like, what? That's it? That's all there? Okay. And you probably maybe even noticed on your, when you graph this on your graphing calculator, it was a really big graph, but all I want you to graph was just what's in this viewing window. Or some of you actually changed the range values and made it, made these like 20s or 30s or 40s. You can do that. Okay. You have that cool mathematical freedom to do that there. But so as of right now, all we have is this one x-intercept, 3/5, right? So that's going to be 1 and 2/5. So it's going to be about like right here. And that's all we have so far. So if we're going to graph a lot more, we're going to need more points. So, let's just see what happens like at 2. So say if I plug in 2 into this whole thing right here, then we would get 20. Well, 2 and 20 is going to be way up here, right? So I'm just going to kind of put a point way up over here. Okay. What happens maybe like at 1, f of 1? Okay, well, if you plug in 1 right there, you're going to get, let's see if I can read my writing on my paper. I don't know if I just do this real quick right here. So that's 3 minus 5 is -2. -2 plus 48 is 46. And then 46 minus about -19 right there. So it's going to be way down here, right? So it's going to be way down here. Okay, that alone right here, I mean, even if you connect, if you connect all these right here, it's just pretty much almost going to be like a straight line. Okay, if you were to kind of go like this, and then just kind of, sorry for the crickedness right there, but just even something like that would have been, because our window range is so small right now that it can't get the full graph. And if you were to zoom out a lot, you're going to get a much better graph there. And then maybe we'll just try a few more points like f of 0. Well, if you plug in 0, 0, 0, it's going to be -80. So as you can see, like we're going to be way down here. And then maybe we'll just do one more for the sake of being awesome. F of -1 is -136. So a lot of these don't even fit on here. But as long as you had these points, because you need 5 points, that means that you show that you knew how to derive those 5 points right there. But that's what I had to do. It's pretty much almost a linear line because we're zoomed in. But if you zoom out on your graphing utility, you're going to actually see the graph do this thing. It actually does do a nice curve like this. But we're like right here. And we're zoomed in so far that it looks like a straight line. But that's fine. For the sake of our graph right here, you would have got your full points if you did that right there. Okay?